Lesson 3, Dynamic Routing. In this video lesson, guys, we are going to speak about dynamic routing and the protocols which are providing us dynamic routing. Also, I'll show you how to make configuration of some routing protocols, and we'll have dynamic routing according to IP version 4 and IP version 6. Let's start. First of all, we'll take a look for a small network in which we have 1, 2, 3, 4, and 5 subnetworks. In case if we want to provide here the static routing, which we did on previous lessons, then we have to make some configurations for router 1. Router 1 directly connected for these 3 networks. So router 1 knows about these 3 networks, but router 1 doesn't know about network, let us say A and network B. So then we will provide information about static routing to router 1 about network A and about network B. Then so it is R1, and let's say this is router 2, R2. R2 also knows about 2 networks, and we have to say to R2 that it has this network, and this network, which are remotely connected. The same job we have to do with router 3. And let's take a look for a medium size network. In this network we have Almaty router, which is connecting to this 5 networks, but Almaty router doesn't know about network. This network, that network, and so on. And you see that when our network growing, our responsibility on configuration is also growing for configuring the static routing. And this is also a medium-sized network, and this is a little bit bigger network, so that when your network is growing, your job is also growing. And here is the map of the internet. And imagine that in internet we have a lot of networks, we have thousands and thousands of networks. And in case if we'll use with you static routing in internet, then we will always work, we as network engineers will always have to work to provide a fresh information about the networks. And it will be not easy, it will be not possible even to provide so many changes by the person who doesn't know about those changes. That is why engineers created dynamic routing protocols which are sharing information. So routers are sharing information between each others by using these protocols, so that routers automatically can send informations according to some changes in the network. Well, we have the routing protocols evolution in this slide. We may see that we have different types, we have different classes of the routing protocols. Let us start from the first division of dynamic routing protocols. Dynamic routing protocols. We have first division and second division. The first division is called interior gateway routing protocols, or we may make abbreviation for it. It will be IGRP protocols. And exterior gateway routing protocols, we can call them EIGRP protocols. Exterior gateway routing protocols. So those protocols which are working inside autonomous system, and those protocols which are working between autonomous system, or we may say outside autonomous system. And now interior gateway routing protocol is divided into also 2 classes, 2 different types of protocols: distance vector routing protocols and link state routing protocols. Whereas exterior gateway routing protocol has only single column, single line. It doesn't have any divisions. So that we'll speak about autonomous systems in next slide, or let me start from here. We have internet. Internet is such kind of network, let us say, and it is divided into some segments of the network, and each such kind of segment is called the autonomous system. Autonomous system. So let me write it here. Inside single autonomous system, there can be a lot of routers which are interconnected between each others and which are exchanging information between each others. And when one of the router will have a new network or will lose a network, for example, here is the new network, network A, then this router will share information about the changes to the neighbors, and neighbors will change information between themselves. And while we have the exchanging of the messages, this process is called the convergence. Convergence is the process when routers exchange the routing information. At the same time, another router, like this one, can lose the network. For example, we had here a network, but now we don't have it. And then router has to send information about it to all other neighbors, and neighbors are exchanging this data. And to provide a limited amount of the convergence time, to decrement the convergence time, we have the autonomous system, so that all routers inside the autonomous system will learn about these changes, and afterward only single packet will travel from one autonomous system to another autonomous system's router, so that this router will say about these changes from the other autonomous system to its own neighbors. Okay, so that autonomous systems are used to distinguish the internet area to prevent infinite convergence process. And those protocols which are working inside autonomous system are called IGP protocols. Those protocols which are working between autonomous systems are called EGP protocols. For example, in one country there can be multiple internet service providers. Like in our country it is Kazakh Telecom. And different internet service providers can get different autonomous systems numbers, and they can be bounded between each other by using the EGP protocols. But inside each of this internet service provider will be different. Inside this single internet service provider, there will be single autonomous system. Then, in our course, we don't have much information about EGP protocols. Here we have examples like EGP protocol, like BGP protocol version 4 and BGP version 4 for IP version 6 protocols. And in our course, we have description of these protocols like RIP version 2, RIP new generation, IGRP, EIGRP, and EIGRP for version 6. The set of protocols are called distance vector routing protocol, whereas in link state routing protocol we'll discuss with you open shortest path first protocol and OSPF version 3 protocol. Now let us pay attention on this table with the types of the protocols by classes. So we have classful protocols line. So these protocols are one of the first protocols in dynamic routing. They are RIP, IGRP, and EGP. So they have common characteristic. It is classful routing protocols. These protocols can work only in classful routing domain. So that if we'll pay attention to that, what is the classes? So let me clear this part. We may find with you classful IP address table which consists of these numbers. A long time ago, when the internet protocol being just developed, engineers created the classes, the main three classes like an A, B, and C. The first octet of IP address, if it was started from 0 to 127, then its prefix being statically given as 8, and it cannot be changed. It couldn't be changed at that time. In case if IP address started from 128 till 191, first octet, the prefix being defined as 16. In case when IP address being elected to be used by you, which started from 192 till 223, prefix being selected as 24. And the rest addresses, like from 224 to 239, the addresses which are defined as the multicast addresses, which are used in the group communication. And the last part, from 240 to 255, addresses are addresses which been used for some experiment. So we can write experimental addresses. Let's continue. Those protocols which has the classification as classful routing protocols were able to work with only classful addresses. It means that in case if router 1 wants to make if you want to make configuration of router 1 with RIP protocol, then you have to be sure that your network addresses are going to be, for example, like this. If you have IP address which is starting with 10, and for example 000, then its prefix will be 8. It cannot be 15 or 16 or 24 and so on. And 172.16 address will have prefix 16. And another example, if your network address is going to be like this, then its prefix is going to be 24. So if you will change the prefix for 25 or to 23, then your protocol will not properly work in your network. Then classless protocols, they can work with classless IP addresses. It means that they can work with the mechanism which is called VLSM, which is abbreviation for variable length subnet mask. It means that our subnet mask and our prefix can be changed. If you have IP address which is starting from 192.168, for example 10, its prefix can be, for example, 30. It is possible. And the domain in which the IP addresses can work is called CIDR, which is abbreviation for classless inter-domain routing. And RIP version 2, EIGRP, OSPF, ISIS, and BGP version 4 protocols are from classless routing protocols, dynamic routing protocols. And the last classification of our protocols are protocols which can work with IP version 4. They are RIP-NG, which stands for new generation, EIGRP for IP version 6, OSPF version 3, ISIS for IP version 6, BGP version 4 for IP version 6. And now Let's take a look for the differences between distance vector routing protocols and link state routing protocols. Differences between these types of protocols are that distance vector routing protocols we can define as a simple protocols. So these protocols are not taking much resources due to the fact that they are very simple. So not takes much resources. Periodically send updates and low, or we may say slow, conversions. Where link state routing protocols are complex protocols. They take much resources. Also, they don't send periodic updates. They have fast conversions. They create adjacency table. Adjacency means that neighbor. They create topology table, and they create SPF 3. It's like shortest past first tree. It is belong to the OSPF protocol. And in other case, so the instance vector routing protocols are simple protocols. Link state routing protocols are complex protocols. And if we'll have with you example that we have network like with router 1 connects to router 2, router 2 connects to router 3, and here we'll have also router 4, and we'll have with you some networks. For example, network A, network B, C, D, E, and F. If we'll use with you simple protocols like distance vector routing protocols, our router 1 will know that it has connectivity to networks A, B, C, D, E, and F through different interfaces. For example, here we have interface gigabit 00, S00, S01. So we'll have here information about them like gigabit 00 and B connects through S00, C connects through S01, and for example D connects through S00, E connects through S01, and E will be connected, or F will be connected through S00 and S01, because we have same connectivity from router 1, two same connectivities from router 1 to network F. And that's it. What router will know about them, will know about it, and also there will be information of the administrative distance about each pass, and there will be metric about each pass. In case if something wrong will be with general pass, for example, one of the network like network E will be lost then router 1 has to make recalculation. Maybe it has, so it had connectivity to network E like this, or let me change my example. Something went wrong on this link, but this network is working properly, but we had the pass from router 1 to network E through interface S01. Router 1 has to make recalculation to find out that now it has connectivity by using this way, because it is possible, but it is taking time to find out from the neighbors, to make requests, and so on. And now let's take a look for what kind of information is stored in the complex protocols like link state routing protocols. Well, link state routing protocols will know information about neighbors. It is first thing. Router 1 will know that it has connectivity with router 4 and router 2. It will know its own directly connected routers, and they will be called neighbors. It stands for the neighbor table. Next thing which will be known by router 1 will know about network A, B, C, D, E, and F. And router 1 will know that it has these networks, for example, directly connected, and directly connected. And router 1 will know that other networks, like network D, E, and F, are connected through different variants. Router 1 will know that to go to network D, it has a variant like it will go to router 4, and router 4 will be connected to network D. Or it can be connected to network D through router 2. Router 2 will be connected to router 3, and router 3 connects to network D. And to go to network E, router 1 will have ability to go through router 2 and then to network E. Or it can go to router 4, and from router 4 it can go to router 3, and from router 3 it can go to network E. And the same with network F, so it can have some variants. So this table, which is created on such kind of routing protocols, will be called the topology table. In topology table, we may see this topology like we see it as people in the graphical view. So with the same logic, router 1 is realizing that it has connectivity with so many networks, with so many combinations. And also routing protocols creates three of the best passes, with the full best passes. And it will be same as if I write it like this. Router 1 is connecting with two networks A, B, C, D, E, and F. Router 1 connects with network A, B, C directly. And router 1 connects to network D through router 4. So here we'll have the best pass. To network E, router 1 connects through router 2. And to network F, router 1 connects through router 4. Router 4 connects to router 3. And router 1 connects to router 2, and from router 2 to router 3, and here we have connectivity like this. So this is called shortest path first tree. This tree helps us to find the full best path. And afterward, link state routing protocols will create, so as you see, topology table. By using topology table, we can create SPF tree in which we have best passes only. And from this tree, a router creates a routing table. So in here we'll have router 1 connects to network A, B, C, D, E, and F. And here we'll have next hop IP address. We'll have here the metric and so on. So it will be, in distance vector routing protocol, we have only routing table. In link state routing protocol, we have such kind of stuff which is helping us to create the routing table. And in case when something went wrong or we have some changes in topology, router 1 will be able to take a look for the topology table, and from topology table it can make decision what to change in the tree, and after we change the tree we can easily change the routing table. This is how you may distinguish, you may look for the differences between the link state routing protocols and distance vector routing protocols. And now let's take a look for the division inside the links distance vector routing protocol. We have two columns here. One column stands for standard protocols, and next column stands for Cisco proprietary protocol. So these protocols can work with any vendor, and these protocols can work with Cisco devices only. They are property of the Cisco organization. They have some advantages according to the standard protocols. And let's start from the first protocol, which is called as a RIP. Some people say that, okay, rest in peace, but this protocol stands, the abbreviation stands for Routing Information Protocol. Version 1, it is classful. It can work only with classes. RIP version 2 is classless protocols. And version NG, new generation, works with the IP version 6 protocols. And IGRP protocol is Cisco proprietary protocol, which has abbreviation of Interior Gateway Routing Protocol. Oh, a routing protocol like this. And EIGRP, stands for Enhanced IGRP. It means that it is improved, and it can work now also with the classless addresses. And EIGRP for IP version 6, the name says what it's doing. It's working with IP version 6 protocols. And OSPF, Open Shortest Path First protocol, which is working with the algorithm of Dijkstra. And OSPF version 3, which is working with the protocols of the IP version 6. Now, let's take a look for dynamic routing protocols in action, and let's take a look for what kind of services provided to us by the routing protocols, by dynamic routing protocols. When you configure dynamic routing protocol on your router starts to generate the updates and send it to the neighbors, and the neighbors are doing the same job, and all of the routers are keeping up to date each other's routing table. So dynamic routing protocol provides us the services of the discovering of remote networks. In case if we have here network A is the foreign network for router 1 and router 3. It means that they are not directly connected to that network, and they don't know about the existence of that network. So that when router 2 will send information to router 1 and router 3 about network A, then in their routing table will have value for this network. Maintaining up-to-date routing information. In case if network A will not be connected anymore to router 2, router 2 will send information about it to their neighbors, to its neighbors, and neighbors will have updated information. Also, dynamic routing protocols are helping routers to choose the best path to destination networks. And dynamic routing protocols provide ability to find a new best path if the current path is no longer available. For example, network A, or let's have now network B, which is connected to the router 3. Router 1 knew about network B that it is connected through router 3. The path was like this. But if something wrong will happen with this link, then router 1, by using help of the dynamic routing protocol, will be able to find additional paths, or we may say the backup path. It's time to make comparison between static and dynamic routing protocols. We will take a look with you for advantages and disadvantages of both of these methods of the routing. Whereas static routing protocols advantages are easy to implement in small network, very secure, no advertisements are sent as compared to dynamic routing protocols, and route to destination is always the same due to that fact that it is configured by the network engineer, or we may say by you. No routing algorithms or update mechanisms required, therefore no extra resources like a CPU or RAM are not required. Disadvantages of static routing protocols are suitable for only small network and configuration complexity growing, because in static routing you can just write the one command IP route and it's quite enough for you. And manual intervention required to reroute traffic. And if something changed in your network, then you have to manually improve your configurations according to new topology. Where are advantages of dynamic routing protocol are suitable. So dynamic routing protocols are suitable in all topologies where multiple routes are required. Generally independent of the network size, so that your network can be small or a very big one. So routing protocol will solve the problem of the advertising the information about the new routes, and automatically adapts topology to reroute traffic if it is possible. Disadvantages of dynamic routing protocols can be more complex to implement due to that fact that you have to know how dynamic routing protocol is working, how to write the syntax of the configuration. Dynamic routing protocols are less secureable because they are advertising through the updates, and updates can be damaged, updates can be catched by someone and can be edited before they can reach the destination. And one of the disadvantages is route depends on the current topology and requires additional CPU, RAM, and link bandwidth. Because routers are generating additional updates, and routers are calculating the best passes, and it takes the CPU performance and the RAM performance to store all of these additional tables. It's time to show you a RIP version 1 and RIP version 2 configuration demo. But before I will do it, I have to tell you a little bit about the functionality of RIP version 1 and RIP version 2. Their characteristics are RIP version 1 and RIP version 2 sends updates periodically. every 30 seconds by default. It's like when you configure router 1 with RIP version 1 or RIP version 2 protocol, this protocol sends information about this network to the neighbor and say, hey, look, I have network 1 and 0. After 30 seconds pass it, this routing protocol says, hey, look, I have network 1 and 0. And another 30 seconds, and everything is repeated after 30 seconds. Hey, look, I have 1 and 0. And router 2 also sends information about network 3.0 and 4.0 to its neighbor router 1. And every 30 seconds, these updates are reaching the router 1, and router 2 also receives the information from router 1. And the same happens between router 1 and router 3. How to make configuration of RIP protocol version 1? You have to penetrate into the configuration of the router, the global configuration mode if it is router 1, and you have to type command like router RIP, and then you will see that you are changing your mode from global configuration mode to router RIP protocol configuration mode, router, and then you have to type directly connected networks. You have to define for router 1 all directly connected networks which it has. So in our case it is network 1.0 and 2.0. Then we'll write command network 192.168.1.0. We don't type any subnet mask or the prefix because we are working with the classful IP addresses. And then we'll type network and 192.168.2.0. And also you have to do the same job on router 2 and router 3. You have to define all directly connected networks. So let us do this job. Here is my pre-configured topology in which we have information about directly connected networks only. So let me write here the command which will show me routing table. In my routing table of router 1, I can see information only about networks 1 and 0 and 2 and 0. Here are they: 1.0 network and 2.0 network. And here you can see L. It means that this is IP address of gigabit 00. And L code shows that this is IP address of serial 00 and 0 interface. And I have to make configuration of router RIP protocol, network, and defining the networks like 1.0 and network 192.168.2.0. Then I will make configuration of router 2 with the configuration of RIP protocol. Router RIP, and I have to define all directly connected networks. They are 192.168.3.0, 2.0, and 4.0. And now let me check router 1's routing table. In router 1's routing table, I can find new routes which are coming from code R, which defines that this is a RIP protocol. And I have two such kind of routes. In this routing table, in these routes I can find the destination's network address, prefix, administrative distance, which is defining the priority of the protocol, and the metric. In the case of the RIP protocol, metric is defined as the number of hops So it means that from router 1 to reach the network 3.0, router has to send the packet, which will make one hop on the router. And if our packet wants to go to network 4.0, it will also make one hop to pass from one interface of the router and to go to another interface of the router. And if your network will be, if your router will know about this network, then we'll have information about network 172.168.30.0 with prefix 24, and our administrative distance, which is defining the priority of the protocol of the route, will be 120. And instead of metric 1, we'll have metric of 2, because our packet will make one jump here and another jump right here. And due to that fact that here we have not classful IP address, so we have classless IP addresses, it will be better for us to continue to work with RIP version 2 protocol. To change the status, to change the version of the protocol from RIP version 1 to RIP version 2, you have to just type version 2 command from one router, it was router 1, and from another router in the RIP configuration. And let's make configuration now of router 3. Router 3 will know about networks, knows about directly connected networks. First of all, we'll change the version to 2, and then we'll define networks 172.168.30.0 and 172.168.20.0. So here are they, 30 and 20. Now, we will check with you routing table of router 3. We still don't have any information about the other networks which are not directly connected, because I think that I forget to type also directly connected network to router 3.4.0. Let me do it. Router RIP network 192.168.4.0, and afterward our OSPF protocol have to work properly. I think show IP route command have to show us. It's not showing me anything. So let me check router 2's routing table. And I also don't have here information about 172 networks. Then I have to also check the RIP configuration by using the command show IP protocols. Alright, here we may find out that we are working with these networks. We are working with version 2. We can send and receive version 2 protocols. RIP protocol. And let me take a look for router 2. Show IP protocol. And here we have these networks. We also can work with version 2. And let us take a look for the filter of the RIP protocol here. And in the simulation, we'll take a look what is happening here. Alright, my update's been sent from router 3 to switches and is not sending to router 2. It is strange. And router 1 sends updates, router 2 sends updates to router 3. Alright, nice. And router 3 sends updates only to networks 30 and 20. Something went wrong now. We'll take a look what's happened. First of all, I will take a look for my IP interface brief table to be sure that serial 000 interface has an IP address. It doesn't have an IP address. It is my fault and I have to improve it. I forget to configure interface as 000 with IP address 192.168.4 and as you see here .2 with subnet mask of prefix 24. Let me save my configurations, and now we can see that you see router 2 received an update and router 2 will send information to router 1 about this networks and so on. Now we have to check the routing table, and in our routing table we may find out that we have network 172.168.0.0 is prefix 16, but we have two separate networks. We have separate network 30.0 and we have separate network 20.0, but router with RIP protocol is sending update to the neighbor that it has connectivity with network 172.168.0.0 with prefix 16, due to that fact that RIP protocol is by default configured with auto summary. And auto summary mechanism, it's taking the classful addresses. It takes non-classful addresses and make from them a classful requests updates. So as you remember, we had classes A, B, and C, and the first bits being like this, first octets till 191, from 192 till 223, and the prefixes being 8, 16, and 24. So our addresses are in the range of class B 172. It starts with 172, and then our prefix being changed to 16, so that our router 3 makes advertisement to router 2 about this two networks as about single network. So as you remember from static routing, we are able to make a summarization of the routes, and this is actually good, but sometimes it can be damage the network connectivity, and due to that fact that it can damage the network connectivity, it is the best practice is to turn off auto summary when you start to configure RIP protocol. And if you will want to make summarization, then you will include it manually, so that in router 3 and in router 1 and in router 2 we'll turn off the function of the auto summary, and we'll go to router RIP configuration and we'll say no auto summary here in router 2. No auto, you can just write the abbreviation, no auto. And now let's switch to the real time and let's fast and forward time. And then after we'll check the router 1's routing table, we have to see two separate networks. They are 172, so here it is, 172.168.20.0 and 172.168.30.0. In comparison, we had only one single line before. And now let's continue with you with that. Our router RIP, routing protocol RIP is sending unneeded updates to switches, as you see. And if switches will be connected to multiple computers, switches will resend this information for those computers. And we don't need to send updates to the switches because it is routing protocols. To turn off the functionality, to turn off updates, sending updates from router 1 to, let's say, end network 10, we have to write a passive interface command and define gigabit 00, so that we don't want to send an update to gigabit 00 because there is no router. And if we'll take a look for the updates on router 1 now, it is sending information only to router 2. But router 2 still sends information to the switch, so that we have to go to configuration of router 2 and we have to type command like passive interface and defining gigabit 00 interface. And when next time router 2 will send update, it is sending only to directly connected routers. There is no update for the switch. This is how we can make configuration of RIP version 1 and RIP version 2. And the mechanisms which you have to know how to turn them off. It is auto summary. It is the passive interface command, which is preventing the updates, preventing the situation when routers are sending updates to the end networks. And it's time to take a look for routing table entries. In here we have the topology, which consists of 3 routers, and these routers are interconnected by RIP protocols. And here we have router 1's routing table. Router 1, if we type show IP route, we can see here information about our networks. We have directly connected entries. They are defined with the C and L route source code. C, it means that this is directly connected network. This place it right here. And L defines the IP address of this interface. It can be seen only in operating systems of the Cisco iOS, starting from version 15 and 1. On old versions, you don't see this L, and you see just only directly connected value. Remote networks can be seen in this way. So we have R, it is RIP protocol. It can be different code. For example, O, it is OSPF, or D, it is EIGRP. We have destination network. We also have administrative distance, which is defining the priority of the route. And here you may find the administrative distance table, which is showing that when you have directly connected network, its administrative distance is 0. When you have static route, its administrative distance is 1. And in our situation, when we use RIP protocol, its administrative distance is 120. The 0 administrative distance is the best distance, and 255 is the worst distance. So that router looks for the best administrative distance to place information about route for the network into the routing table. After this slash, we have value, which is called the metric. Metric in RIP protocol is defined as the hop count, but in different protocols we have different metric types. Some protocols are measuring the best path by using the bandwidth. Some routing protocols are using the as a metric composite metric evaluation, like an EIGRP protocol. Next, after the metric, you can see next hop address. Next hop address, it is the next router's IP address. For example, in case you have router 1 and router 2, and if you have connectivity to network A from router 1, next hop IP address to network A will be IP address of this interface. For example, like this. But in our case, it's next hop IP address. Next thing, it is a route time stamp, which is defining how long your router knows about this route. And next is the serial 000 interface. In our example, it is outgoing interface from the router. So S000 interface. So our router 1 will exit to the network A through this interface. Routing table terms. We have different terms, different types of the routes. They are ultimate route, level 1 route, level 1 parent route, and level 2 child routes. Ultimate route, you can see them in the projection. An ultimate route is a routing table entry that contains either a next hop IP version 4 address or an exit interface. Directly connected, dynamically learned, and local routes are ultimate routes. For example, look, this route, for example, for network 172.168.1.0, we have exit interface. We have next hop IP address and next hop IP address. But some of these routes doesn't have, you see, any like exit interface or next hop IP address. They are not called ultimate routes. So ultimate routes are routing table entry which consists of next hop IP address or exit interface. Level 1 route. Level 1 route is the route with a subnet mask equal to or less than the classful mask of the network address. Therefore, a level 1 route can be network route, whereas network route is the route that has a subnet mask equal to the classful mask. For example, you have 192.168.10.0 network with prefix 24. It is called network route. Or you have 172.168.0.0 with prefix 16. It is also example of network route because the prefix is equal to the prefix of the classful route. Supernet route is the route that has less mask than the classful route. For example, 192.168.10.0 with prefix 23. This route is the supernet route. This route is a network route. Or 172.168.1.6.0.0 with prefix 15, for example, or even less. This is also the supernet route. This routes can be this supernet route is a route network address with a mask less than the classful mask, and for example a summary address. Default route is static route with the address like this. Okay, it also has the description like level 1 route. And here we have with you examples of level 1 route. Level 1 parent route. Level 1 parent route is the route which doesn't have exit interface or a next hop IP address. So as you see here, and which are created automatically. And this routes have the child route. Let's take a look for the child route and why they are created. So look, we have networks like 172.168.1.0 with prefix 24. You have network 20 with prefix 24, 30 and 40 with prefix 24. But if we'll take a look for the classful addresses, 172.168.1.6.0.0 network. If your first bit octet is like this, then your classful prefix will be 16. But in case if your prefix is greater than 16 than the classful prefix, then router automatically creates this parent route, and under this parent route it is placing the child routes which have higher value of the subnet mask, higher than in the classful subnet mask, classful IPv4 addresses. And look, parent route is generated automatically by the router in case if in your routing table there are some network addresses with the prefix which is higher than in the classful prefix. And parent route is not the ultimate route, but the child routes are ultimate routes due to the fact that they have exit interface or next hop IP address. How router makes a lookup process? First of all, the very first thing what router is checking in the routing table, it is the level 1 routes. Router checks if the destination network is a level 1 route, and if it is ultimate route, Then information is sent through exit interface. Next thing, so this is first. Next thing, which is for what router is looking up, it is parent route. And if our destination network is the parent route, then router looks for its childs. For example, we have the packet with destination network address like this 172.1.6 and 3.3.0 with prefix 24. So look, router first of all looks for the first level, it cannot find it here, then it looks for the parent route and it is searching it. Okay, so look, sorry, like this. We have parent for this route, and then router looks up for its childs, and it is searching for network 3.0. Actually, here we have 0. And after it will find it out, it will resend it through the exit interface. But in case if we don't have, if we have a destination IP address which is not in the child route, for example, we have destination network address which is looking like 5.0 with prefix 24. Then router will not find it out, and after what, router will look for the supernet routes, and one of the example of supernet route is the summary route. So summary route so router looks for a summary route. After it will take a look for first level 1 routes, parent route and child route, and only then it will look for the supernet route. And if it will not find it in the supernet route, then it will look for the default route if it is existing. And if it will not find it in the supernet route, then router will send the packet through default route, because default route, it is like a backup. I don't know where to send you, you go there, maybe you will be successful. IP version 6 routing table entries. It is familiar with the IP version 4 table entries, so that we have directly connected networks. They are also defined with the CNL, and we have the information about the administrative distance and the metric, and we have via through which outgoing interface we are connected. And remotely connected networks, we also have these values, like this is our administrative distance, this is our metric on the EIGRP protocol, this is IP address of the next hop IP address, and this is our exiting interface. And by the way, the main information is destination network address. This is the end of the lesson, which is describing the fundamentals of the dynamic routing protocols and the classification of them. I hope that this video been informative for you, and I hope that you will enjoy next lessons. In next lesson we will take a look for the basics of the switching in the local area network. And see you again, guys.